Okay, we're going to take a look at how to find a specific term when we do a binomial expansion. So I put this binomial expansion out already for you so that you could see the patterns that we talked about, okay, or that we are going to talk about. So if I wanted, say, the third term of this one, right, I could go about going all the way and expanding the whole thing and then saying, well, this is my first term, this is my second term, this is my third term, this is my fourth term, and this is my fifth term. Okay. Well, if we want the third term, that means we're looking at this one here. Okay. So notice if we're looking at the third term, if I look at this power, it's a 2, and this power is a 2. Okay. This one is the one that we want to look at. Every time, so notice we've got the first term, and then this one is 0. This is the second term. This one is 1. This is the third term. This is 2. This is the fourth term. This is 3. This is the fifth term. This is 4. So whatever term that we have, we're going to go one number less than that, and then that becomes the power for our second term. So let me say that again. So the power, for the second term is 1 less than the term number you are looking for. And that's because, notice we start counting here at 0. So 0, 1, 2, 2, 3, 4, right? So if I want the third term, we're starting counting at 0. Or you could use your fingers and start where you do your 1, 2, 3 fingers, but you say verbally 0, 1, 2. So then you're matching, your third finger goes with 2. Whatever way you want to do it is fine. So whatever term you're looking for, it'll be the second term raised to 1 less than that. Okay? So if you're looking for the nth term, for x plus a to the n, okay? Let's not say n, 2 n's. Maybe a different letter. Let's do m. Okay? So we're looking for the nth term, so I'm going to take whatever our a value is, and I'm going to raise it to n minus 1. Right? That's what we're saying. We go 1 before the nth term. Okay? Now, if we look here, we've got a couple other things that we can notice. If we look at the 2 powers, here we have 4 and 0. Here we have 3 and 1. Here we have 2 and 2. Here we have 1 and 3. Here we have 0 and 4. Hopefully you can see all of these add up to 4. So in each term, you have the powers add up to this power that the binomial is being raised to. So this adds to 4, this adds to 4, this adds to 4, this adds to 4, this adds to 4. Okay? So that means if we wanted the third term, right, in our example, we know that that would mean that we would need, there we go. Too many things I'm hitting. If we wanted the third term, we're looking at this power of 2. Well, I know I need to get to the fourth power. So 2 plus what gives me 4? Well, 2 plus 2 gives me 4. So then my first term from the binomial expansion, that power will be the 2. Okay. Then notice I like to, when I'm finding a term, use the combinations instead of Pascal's triangle. Now I put Pascal's triangle up here so that you could see it. But notice here that on our combinations, the right side matches your second term power. So the 2 matches the 2, the 3 matches the 3, the 4 matches the 4, the 0 matches the 0. Okay? So that way I don't have to go make a whole triangle just to find one term. So let's try an example. So if I give you, come on, there we go. 5x plus 3y, I don't know, let's do the to the 20th. And we want to find the 17th term, right? You do not want to find all of them for this expansion if you just want the 17th term. That would be a lot of extra work that we don't care about doing. Okay? So if I want the 17th term, that means I want to go 1 less than that. So I'm going to take the 3y, and I'm going to go 1 term less than 17. So I'm going to do 17 minus 1, which gives us 3y to the 16th. Okay? Then I'm going to do the, oh, I already did yellow. Oh, that's pen. I wanted highlighter. I'm going to do the 5x, and I'm going to take that thing to the power so that they add to 20. Right? So if this is 16, I'm thinking 16 plus what equals 20? Well, 16 plus 4 equals 20. So this will be 5x to the 4th. Okay. Well, now I need to find the coefficient for the binomial. Now I could go start making by Pascal's triangle and then go all the way down till I get to my second number is 20, which is a ridiculous amount of work. So instead, I'm going to use combinations. Well, with our combinations, remember, the pattern is that it's always whatever the power is that you're being raised to is the first n part, and then the r value matches the second term power. Right? So that means here, I'm going to do, since it's 20, I'm going to do 20, choose, and then it has to match this 16. So 20, choose 16. So if I do 20, choose 16 on the calculator, remember it's under math and then probability, so you get 4,845. If we raise 5 to the 4th power, that is 625x to the 4th. And if we raise 3 to the 16th power, that's going to be 4304671y to the 16th. And then we would have to multiply these numbers together. So the really long number times 625 times by 4,845, which gives us a really long number. It's 1.304 times 10 to the 14th, x to the 4th, y to the 16th. Normally I won't give you such large numbers, so you won't have to write it in scientific notation or write 14 digits after that. But the idea was that you can see that you can find it even with really large numbers. So then this would be our 17th term of this expansion. So it's nice to be able to see the pattern for terms as well, so that if you need just a term, you don't have to figure out the whole expansion and do all this extra work.